Sir Isaac Newton's first law of motion, otherwise known as inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted on by an outside net force. That being said, there are many forces on Earth for which we as physicists need to account. So when one, for instance, throws a football forward up into the air, why does the object not stay in motion at a constant velocity, as Newton's first law would state? The ball does not continue to fly forward in the air forever because it is acted upon by many outside net forces, like gravity, for instance, which is pulling it closer to the ground. The ball is also acted on by other forces, such as the force of the hands of my partner and I pushing back on the ball as we catch it. So, in an isolated system in which there is no gravity and no other objects that one could hit with the football, the ball would go much further in a straight line and a constant velocity as long as no other net force is acted upon it. Another interesting thing to note about the physics found in football is the parabolic arc that is made by the path of the football that is thrown. At each stage in its parabolic path, the ball carries a different amount of potential versus kinetic energy. Potential energy is the energy an object has due to its position rather than its motion. And vice versa, kinetic energy is the energy an object has due to its motion and not its position. In this photo, right as the ball is released, kinetic energy is at its max and potential energy is at zero. In this photo, at the height of the ball's path's arc, the potential energy would be at its max and kinetic would be at zero. In this final photo, as the ball nears its lowest point on the parabolic arc, kinetic energy is once again at its max and potential energy returns to zero.